All right, let's dive into this new architecture for LLMs that everyone's talking about. So we've got a whole stack of research papers about it.
Right.
That's called MoBA, short for mixture of block attention.
Yeah.
And we're going to try to unpack what makes this approach so potentially groundbreaking for handling long context language models.
Well, the core issue here is scale.
Right.
Scaling LLMs for truly long context, like we're talking millions of tokens.
Oh, our listeners got something to share. Let's hear it.
Hey there. Can we go through the abstract and introduction part of this paper?
Hey there, absolutely. I'm happy to walk through that with you.
Great idea. It'll help frame everything.
So if we look at the executive summary, it says that MoBA improves the efficiency in LLMs.
Okay.
It dynamically selects relevant blocks for each query token.
So it's like a smart filter.
Exactly. It reduces computational complexity, transitions seamlessly between full and sparse attention.
Making it super flexible.
It's been deployed to support Kimi's long context requests.
Which is a huge real-world test.
Exactly. Now, if we connect this to the bigger picture, the traditional attention mechanisms just don't cut it.
They can't.
Right. Their quadratic complexity means they become wildly inefficient.
Okay, so how does MoBA tackle this computational bottleneck?
It borrows a concept from a seemingly unrelated field, actually.
Okay.
It draws inspiration from the mixture of experts principle.
Okay.
It's typically used for model parallelization.
Right.
Imagine splitting a massive text to smaller chunks.
Okay.
Or blocks.
All right.
So MoBA doesn't try to process the entire sequence at once. Instead, it uses what they call a gating network to selectively route each query token to only the most relevant blocks.
So it's almost like a triage system.
Exactly.
For information.
Exactly. And this selective routing dramatically reduces that computation burden, allowing MoBA to handle sequences of 1 million tokens or more.
That's amazing. But this block-based approach raises a question.
Sure.
Doesn't it risk sacrificing the model's ability to capture those long-range dependencies? And we're talking about those crucial connections between words.
That's where MoBA's careful design comes in.
Okay.
It maintains causality by ensuring that a query token cannot be influenced by future tokens.
Okay.
So while it processes information in blocks, it still respects the sequential nature of language.
Okay, so MoBA selectively attends to information while still preserving the order.
Exactly. Hey, yeah, what's up?
Go through the method part.
I'm happy to do that. I'll walk us through the method.
Great idea. That'll help us understand how it all works.
Okay, so in terms of method, MoBA partitions the context into blocks.
Right.
And uses a gating mechanism to selectively route query tokens.
So it's like directing traffic.
Yes, and to the relevant blocks.
Gotcha.
This block sparse attention reduces the computational costs.
Okay, so it's more efficient.
Exactly. Now, if we connect this to the bigger picture.
Right.
MoBA ensures that a query token cannot be routed to future blocks.
Okay, preserving causality.
Exactly, and it applies causal masking.
To prevent information leakage.
Within the current block.
So it maintains order.
Exactly, it does.
Okay, I see. But the papers also mention a fine-grained block segmentation.
Yes.
As being pretty key here.
Think of it like adjusting the resolution of your lens.
Okay.
A fine-grained block segmentation allows MoBA to focus more precisely.
So it can really zero in.
Yes.
Much more effectively.
Exactly.
Okay, but what about tasks where considering the entire context is crucial?
Right.
Can MoBA adapt to situations that might require a more global perspective?
That's where its hybrid nature shines.
Okay.
MoBA can actually seamlessly transition between full attention and its block-focused approach.
Oh, so it has both.
Yes, it can switch modes depending on the specific demands.
It's like having a car with both an eco mode and a sport mode.
Exactly.
You choose the best setting.
Yeah.
Now, the research delves into some pretty compelling experimental results.
Yeah.
Particularly with scaling law experiments.
Yes.
What did these experiments reveal about MoBA's performance?
Well, the researchers put MoBA head-to-head against full attention models.
Okay.
And across different scales.
It achieved scaling performance that was comparable to full attention.
So it's not just efficient,
right.
It's surprisingly effective as well.
Yes.
As we touched on earlier, MoBA can handle massive contexts.
The million-token behemoths.
That's where things get really interesting.
Okay.
The researchers found a curious pattern in MoBA's performance.
What did they observe about those trailing tokens?
Well,
it seems like that would be the point where MoBA's approach might struggle.
You would think so.
Yeah.
But they found the opposite.
Really?
The performance gap was actually most pronounced in those trailing tokens for shorter contexts.
Okay.
As the context length increased, that performance gap narrowed.
So MoBA actually gets better at handling those trailing tokens
Yes.
as the text gets longer?
That's so counterintuitive.
What could explain this behavior?
It suggests that MoBA isn't just blindly hopping between blocks.
Okay.
As the context grows, it becomes increasingly adept at identifying crucial information.
Wow.
Allowing it to maintain strong performance on those final tokens.
So it's not just about efficiency.
It's about selective attention.
Learning to focus on what truly matters.
Exactly.
But the research highlights how MoBA was successfully deployed in a real-world LLM.
Right, called Kimi Chat to handle those long context requests.
Okay, so MoBA is already out there.
Yes.
That's incredible, but the researchers didn't stop there.
No, they didn't.
They also put MoBA through its paces on various long context benchmarks.
What were the results?
They evaluated it on benchmarks like Longbench and Ruler, and the findings were compelling.
Oh.
It sounds like MoBA is shaping up to be a real contender.
It really does.
But before we dive deeper into those benchmarks and its real-world applications.
Let's take a step back.
Okay.
MoBA isn't the first attempt to solve this long context challenge.
Right.
There have been other approaches to creating more efficient attention mechanism.
Okay. That's what we'll explore next time.
So before MoBA, researchers explored a bunch of different paths.
Yeah.
One prominent approach was static sparse attention patterns.
Static sparse attention. These techniques basically predefine which parts of the input sequence each token should attend to.
It seems like there's always a trade-off.
Right.
What about approaches that don't rely on these predefined attention patterns?
That brings us to dynamic sparse attention.
These techniques are more adaptable.
Oh yeah, let's hear it.
And can we wrap up the conclusion with the key points and the main takeaway?
I am happy to do that. Let's wrap up by summarizing.
That sounds great. It'll give us some solid takeaways.
So MoBA is all about efficiency and scalability.
Right.
Using blocks to reduce computation.
It's inspired by mixture of experts, or MoBA.
But adapted for attention mechanism.
And it can switch between full and sparse attention.
Right.
To adapt to different situations.
MoBA can also handle really long contexts.
Like those million token texts.
Yeah, and it's even deployed in Kimi Chat.
So it's not just theoretical.
Exactly, and remember how it improves
on trailing tokens as context gets longer.
That's a key advantage for conversations.
The main takeaway is its flexibility.
And it balances performance and efficiency.
Okay, so before we end,
right.
MoBA isn't the first attempt to solve this long context challenge.
There have been other approaches.
Okay, that's what we'll explore next time.
So before MoBA, researchers explored a bunch of different paths.
Yep.
One prominent approach was static sparse attention patterns.
Static sparse attention.
These techniques basically predefine which parts of the input sequence each token should attend to.
It seems like there's always a trade-off.
Right.
What about approaches that don't rely on these predefined attention patterns?
That brings us to dynamic sparse attention.
Okay.
These techniques are more adaptable.
Interesting. So what would be an example of that?
One example is the reformer model.
These dynamic approaches sound promising.
They are.
The trade-off here lies in computational costs.
Yeah, that makes sense.
It's a constant balancing act.
Mm-hmm.
So it sounds like the ideal solution.
How does MoBA fit into this picture?
Okay.
It retains the ability to switch between full attention and its block-focused approach.
Okay.
So it can go back and forth.
Wow.
Similarly, attention sinks, which concentrate on a combination of initial and recent tokens.
So MoBA offers a more versatile framework.
Right.
That can adapt to a variety of scenarios.
Precisely this flexibility is one of the reasons MoBA is so exciting.
Yeah.
It's not just a specialized solution for long context.
That's huge.
But to truly appreciate its impact, we need to go beyond the theoretical.
Yeah.
And look at how MoBA performs in real-world applications.
Let's do that.
Okay.
Next time, we'll delve into the specifics of MoBA's real-world performance.
Right.
Including its use in Kimi Chat and the intriguing findings about those trailing tokens.
They do.
That MoBA excels in handling long context.
They do.
Okay, so let's dive into some real-world examples of MoBA in action.
Okay.
The research mentions its use in Kimi Chat.
Right.
An LLM that was specifically designed to handle long context conversations.
Yes.
So can you tell us a little more about how MoBA is actually being implemented there?
Sure.
And what kind of impact it's having on the user experience?
Yeah, so Kimi Chat is a great example of how MoBA can push the boundaries of what's possible. This means that users can have more natural, in-depth interactions.
So it's like finally having an AI that can follow a long, nuanced discussion
Yeah,
without losing track of the thread.
exactly.
And that